This is video number 3 for sections 8.6 and 8.7, Variation Problems, Basic Ideas. Remember, here at the end of Chapter 8, we're just looking at applications where solving a rational equation is involved. We did average problems, and now this is a completely different type, unrelated, called variation problems. Really, we're borrowing this from science. Variation is an idea that's heavily used in science when you have two variables that are related by a constant. And there are two types that we're going to consider. The first type is called direct variation, and it goes like this. We say y varies directly as x, so one variable varies directly as another if, what does that mean? It means that one variable, the y, is always calculated by taking some constant, some fixed number, and multiplying it by the corresponding x value. And that's true for all the values of x and y in that particular problem. X and y are variables. They change, but that k is a fixed number. It's usually pretty easy to spot direct variation from a table. So take a look at this simple table. I've got some x values, some y values. You can see the matches. The first question is, what's the equation for the table? Well, hopefully that's not too difficult here. 2 gets matched with 10, an x of 3 turns into y equals 15, 4 with 20, 5 with 25. The question is, how are they calculating these y values? Well, hopefully what you're noticing is that each time the y value is simply the corresponding x value times 5. The equation is just y equals 5x. Right? 2 times 5 is 10, 3 times 5 is 15, and so on. Well, that means this situation, this table, fits this direct variation definition. The next question says, what's the value of the k? Well, obviously in this problem, the k is 5. In any particular problem, the k will be some set fixed number. And in this case, the k is 5. We could say the y values vary directly as the x values because, again, it fits this pattern. Last question by way of introduction here with direct variation. As the values of x increase, what happens to the value of y? You can see the x is going up, 2, 3, 4, 5. We'll take a look at the y's, 10, 15, 20, 25. They increase as well. The main thing you need to remember is that when you read the word direct in association with variation, this equation needs to come to mind, y equals k times x. Well, there's a second kind of variation that's explained here, and that's called inverse variation. Let's take a look at the definition. We say y varies inversely as x if instead of each y being a constant times the x values like it was before, now each y is some constant divided by each x value for all the values of x and y in that particular problem. Again, k is some fixed constant. Now, I would say in general, this is tougher to spot from a table. I made a table here. Here's some x's, here's some y's. This is an inverse variation table, so me telling you that certainly helps to identify the pattern. You're trying to figure out what constant I kept using to divide by each x in order to end up with the y. It is a little bit tricky to see. I think probably the best places to see it are in this column and this column, partly because you can actually see the division taking place, right? Here I had 3. The answer is 4 divided by 3. Here I started with x equals 5. The answer is 4 divided by 5. It looks like the constant that I kept using was a 4. In other words, I think the equation here is y equals 4 divided by x. Let's check it out. 4 divided by 2 is 2. It works. 4 divided by 3, 4/3. 4 divided by 4 is 1. that works. 4 divided by 5, 4/5. I think we've got it. So this equation fits that inverse variation pattern. The value of the k in this problem, of course, is 4. And the final question, as the values of x increase, this time what happens to the values of y? You can see the x's going up in the table, 2, 3, 4, 5. Look at the y's. 2, 4/3, that's like 1 1/3 or 1.333. Then 1, then 4/5, which is like 0.8. These y values are decreasing this time. With inverse variation, as one variable increases, the other variable decreases. Again, the main takeaway here is when you read inverse variation, you need to memorize this associated equation, y equals k divided by x. Before we look at the full problems, we need to do just a little bit of practice in writing general variation equations. General variation equations just mean equations with the letter k still written in them. Take a look at the example problems here. Letter A, w varies inversely as the square root of t. When you read that, you have to be able to turn that into a general variation equation. Of course, the word inverse means that I'm talking about this second guy, the one with the division. And all I have to do is put the right letters in the right places here. This time my opening letter is a W instead of a Y. So I write W. And then since I'm doing inverse variation, I know that always means some unknown constant divided by the second item. Well, the second item, w, varies inversely as, it's a little bit more complicated, the square root of t. That's what goes down here. This is the equation version of this statement. W varies inversely as the square root of t. Let's try another one. Letter B, I varies directly as x plus 2. Again, the word varies tells you that we're doing a variation problem, and this one is direct variation. Direct variation means I'm going to use that original formula, the one that was y equals k times x. Right? That's what you memorize for direct variation. And then just put the right pieces in the right places. I have I this time instead of y. Varies directly means equals some constant times the second guy. And this time the second guy is a little bit more complicated. It's x plus 2. This says I varies directly as x plus 2. Remember, this has all been by way of introduction. In our next video, we'll go ahead and work a couple of the full variation word problems.